Hello there everyone and welcome to day 3 of the Pandas challenge. My name is Valentine and I'll be your instructor. In this workshop, we are going to be going through a set of problems related to Pandas that will help you become better at working with the Pandas library. So let's get started. The first thing that you need to do is to visit the link in the description section of this video, and it should take you to a page that looks like this. Then once you get here, just click on the sample practice resource link. Once you have done that, you should have this open. So this is a notebook that will contain the set of concepts that we are going to be covering in this session. All right. By the way, feel free to pause the video. And if you also feel like I'm a bit fast, you can always rewind to just catch up with some of the concepts that were not quite clear. Okay, so let's get started. So once you get here, click on Profile, then save a copy in Drive to save a copy of this notebook. It should open in a new tab, and you can use that copy to work on in this session. So yeah, so let's do that. I won't save mine. I actually use the practice notebook, which is an enhanced version of this notebook, which has all challenges for each and every section. This practice notebook is accessible to Afterwork members. So if you want, you can always consider also becoming an Afterwork member, and you get access to all the resources that we've ever produced. And in addition, for this particular workshop, you'll get a solution notebook that contains solutions, sample solutions that you can use to verify your solutions. So yeah, so once you get there, once you've saved a copy in Drive, the next thing that we need to do is to connect our notebook to Google server. So you can click on the link at the very top right, click on that. So it should take a few seconds, it has connected, so we should be good to go. Let's move on and start by importing the Pandas library in this section. Just run anyway, then we'll have imported the Pandas library for data manipulation. So once we do that, we can get started with the first concept, which entails selecting columns. Sometimes you might want to do this when we are working with data, because we may not want to work with an entire data set. We might only want to work with just a number of specific columns in order to answer a research question. So yeah, so let's load the data set that we're going to be working with, which is this data set. And what we want is to select the first name, last name, grade, math score, as well as the science score. So these ones over here, these columns are the ones that we are interested in. And how do we do that? We reference the DF data frame. So actually, we can do it this way. First of all, we create a list, a Python list that contains items of which represent just the column names that we are interested in. So this list, which will contain the Python list, will define the column names that we want, and then we pass the list. Okay, we store it in selected columns variable, then we pass it to df in square brackets. So this is the original data frame, and we should be able to get this the data that we are interested in, and we can display it here. Right, pause the video and then work on the challenge, and then we can continue. Moving on, Boolean indexing. Sometimes we might want to not select the columns. We might want to now select or filter the records by a specific column. So for example, here we have selected just columns, but now what if we now wanted to filter where the grade is 10, so that we have just records for 10th grade students? So how do we do that? We use one of the ways, which is Boolean indexing. It's a standard way of selecting or records based on a particular criteria. So yeah, so let's get to learn how to apply that. So that concept, so let's load this new data set that we have, which will contain just information about students. And if we want to get students with mathematics score greater than 90, so this is the column of interest, how do we do that? So we create what is called a Boolean index, a mask. It's called just a Boolean mask, which just is a condition. So here in our case, we have the column of our interest, and then we write down the operator that we want to use. So we want to check for DF math score, which is greater than or equal to 90. So for students who have math score greater than or equal to 90, and that is just a Boolean mask that we create, or the condition that we're going to be working with. Then once we have done that, we can then pass it to the data frame, the DF data frame that we had earlier. Then we store that in maths parts and display that in the next section. And you can see here the maths score records have values greater than 90 and or equal to. All right, pause the video and then work on this challenge. Moving on, we can decide to remove duplicate records or rows because they might impact our analysis or our results negatively. You don't want to depend on data that has duplicate records. Maybe if you wanted to count the number of students within a class and you have duplicate records, then that would, give you, the data set would give you the incorrect number of students in that particular class. So you might want to just delete the duplicate records. So let's get to learn how to do that. So we'll load this data set, which also contains students. We can remove duplicate rows based on all columns. So if all the columns are equal, then we can decide to remove them as shown over here. So we use the drop duplicates function, which we apply to the original data frame, DF, and store, and what will be remaining here on the left-hand side would be those records that do not have any duplicates based on all the columns. But if we had maybe a specific column, wanted to define duplicates as records with maybe similar number of, let's say, a good one would be, maybe we just wanted to even get maybe a random sample, and we could define duplicates based on even just student ID. Student ID would work. So we could just use a list, then we type in student ID. It has to be equal to the column name that you have there. But for now, we just want to drop the records with duplicates based on all columns. All right, moving on, pause the video by the way and work on the challenge. Moving on, we might want to create a summary table out of a larger table. So it helps us to create just a pivot table, in other words. So let's learn about data aggregation. So we'll run this particular code to just preview the new data set that we are working with. And to create a summary table or pivot table, we can use the group by function. And you can first of all think about or visualize the data, the summary table that you want. On the left-hand side, you want grade, and on the right-hand side, you want math score, but you want the mean of the math score. So for each grade, we want to have the math score average. So we use a group by function, which we apply to the original data frame. Then we specify the grade, which is what we want, the category that we want to use for grouping, that's the variable that we want on the left-hand side of our summary table. On the right-hand side, we want math score. And this variable usually needs to be a numerical variable. And then we apply some aggregate function. Could be mean, it could be count, it could be sum, it could be max, etc. Then we apply the reset index column, the reset index function to be able to get a pandas data frame or at the very end. So, if we run this, we should be able to get this. We have grades, and then we have the average scores for that. And we can use this data maybe for other purposes, maybe for creating a visualization, maybe a pie chart or a bar chart to compare the different categories. Pause the video and then work on the challenge. Moving on, grouping and aggregating based on multiple columns. So here we had, we grouped based on maybe just grade. So assuming that we wanted to group based on another column, maybe another category, then we can do that. So in our case here, let's do this. So we've run this particular code. I'm trying to look at the the other category here, but the one that I see isn't the best category. We have attendance, which we are grouping this, it as. So here initially we specified just one column to group by, but here we have two columns, so we might want to group by grade then attendance, but it may not be the best one. So we could maybe have male, female, so that for each grade we have a gender. So that we have now the average math score, say for if this were gender, we would have math score for female, math score for male, etc. So in our case over here, as you can see, we also want to have other multiple numerical variables in terms of our in our summary table as well. So if I apply this, you should be able to see that attendance, where it was 85%, we had an average score of a maths average score of 75, science 78, etc. But generally here, what we're doing, we are grouping by multiple columns, and at the same time, we are also getting the values within our summary table, which are also across multiple columns. Here we had just one, but we just changed this string into now a list, and then we added more items which correspond to the column names to that particular list. Pause the video and then work on the challenge. Data reshaping using pivot tables. Sometimes you might want to change the format of our table. Data reshaping just involves changing a format of our table, maybe from how the values have been presented, or in maybe column format or row format. But there are various techniques for data reshaping. And they might be important because sometimes you might get some visualizations that require you to reshape your data. Like you can use what is called a meld function, etc. In our case here, we can decide to, actually here we're creating a pivot table, and we are reshaping our data using a pivot table. So the pivot table function. So this is the data that we have. And what we want to have is on the left-hand side, we want to have grade, almost like what we had here. Then here we have on the right-hand side, we want to have math score, science score, English score, history score. Then we want to apply a mean function. So it's almost like what we did here, but reshaping has many other techniques. This is just one of them, but there are other techniques that we can get to apply. Actually, this is not a good example of reshaping, but you can just work on it, just get a hang of the pivot table function. I'll provide some more reshaping examples in further challenges, other challenges that are to come. All right, pause the video and then work on the challenge. Feature construction. So sometimes you might want to create new features. So for example, if we have this data set and maybe we wanted to have another column, so we can decide to, let's say, create maybe total score. So we have math score, science score, English score, history score. But if we wanted to have another column called total score, that's a result of these four values, then we can create that new column as shown. So we first of all reference the original data frame, use square brackets, and then we use a new name for the new column. Then we equals it to, now on the right hand side, this is our operation. So we want to have total score to equal to math score values plus science score values plus English score values plus history score values. So the outcome for what would be on our right side would actually be the value for total score across all rows. So we'll create a new column called total score with now an aggregate of those values for those columns. Average score. So there's also average score which we can do. So average score would be the mean of all of them. So we can decide to reference the columns that we want to calculate, to use their values, and we apply the mean function, and we set that we want to apply across the rows themselves. So that's what we do in the next in the next line, and we preview the updated data set with the new features. So here you can see that we have total score as well as average score on the far right. Pause the video and then work on the challenge. We can also select data using iLock. This is one of the methods that we can use to filter data. So we can decide to select for data, more like what we did here. So with Boolean indexing, we used, we specified a condition, but with, here we specified a condition. Actually, it's slightly different. With Boolean indexing, we can be able to specify some condition, whether it's one or multiple. But with iLock, we can just select data across a certain range. So for example, if we wanted to select the first 5 rows and maybe the first 3 columns or the last 3 columns or the second to last column or second to third column, we can use this method. So what we do is we reference the original data frame, then we use iLock, then square brackets. Then what comes over here is the rows. So we specify that we want to select the first 5 rows. So from 0, then to the 5th row, we use a double colon. Then comma, what would be on this other side would be the column. So from 0 to the 3rd column. So rows and columns. You can specify even from, let's say it's, if you wanted maybe from the not from the first one, from the second one, from the second one would be like that. So from index 1 to 5, etc. So yeah. So let's run this, and we should be able to, let me undo. We should be able to get the first 5 records and the first 3 columns. So we're just generally using indexes here. And you'll note here that we are specifying for the columns, we are not using 2. One would think that we start from 0, 1, 2, but no, we are using the next index. So here it's slightly different. Actually, even here, it's actually slightly different from 0 to 5. So we are selecting the rows with index. These are the indexes that I'm talking about. So we are selecting the rows with indexes 0 to 4 by specifying what we are doing here. So we are specifying 5, which simply means we'll select rows with index from 0 to 4. The same case here, we select columns with indexes 0 to 1, 0 to 2, sorry. Pause the video and then work on the challenge. Correlation analysis. Sometimes you might want to determine whether there's a relationship between 2 variables. So for example, if we load this data set, and we have here, we might want to determine whether there's a relationship between English score and science score. Like, do values of English score increase while the science score increase as well, which might mean, stakeholders might say if they do, then we need to focus a bit more on maybe English score. So as students get to understand more of English, then they're likely to do the same case with science score. But I think it's, well, you might think of it as maybe on the history side, because there's a lot of facts, but I don't know. Based on the data that we have, we just want to determine whether there's a correlation between the two. So what we can do is to specify that we want to apply what is called a correlation function. So when it comes to calculating determining that whether there's a relationship, there are many methods we can use. You can use a visualization technique, such as creating a scatter plot, or we can determine what is called a correlation coefficient, which helps us to understand to what extent those 2 variables are correlated. So values closer to 1 would mean that the values are strongly correlated. Values closer to -1 would mean they're negatively correlated, but values closer to 0 would mean that they are not correlated at all. So here what we are doing, we are specifying the original data frame, then we specify the columns that we want to work with. They have to be numerical columns without any missing values, and then we apply the core function to be able to calculate the correlation coefficient. There are different types of correlation coefficient values. Okay, there are different methods that we can use determine the correlation coefficient. But the common method that we use is the Pearson method. And what this technique will do, it will not necessarily give us a number, it will give us a table or correlation matrix that we can then analyze. So here we have a correlation matrix, which simply means English score versus science score 0.48. It means they're correlated, but not strongly correlated. It's not closer to 1. It's like, and it's actually on the end of towards 0, as opposed towards 1. If it was greater than 0.5, then we could say there's a very strong correlation. But yes, it's still, you can still say that there's some strong correlation between the two. Right, pause the video and then work on the challenge. Data visualization with pandas. So when it comes to creating data visualizations, there are specific libraries that we can use. There's matplotlib. There's also Seaborn for creating statistical data visualizations. But in our case, what we are going to learn here is that we are going to use Pandas. Pandas has the plot function, which just allows us to create some basic function for some basic plots. So let's get started and get to learn about that. So we'll run this. So here we are loading our data set, and what we want to do is to create a histogram. A histogram is a type of visualization that allows us to understand the distribution of a numerical variable, and it can just tell us whether the data points are skewed to the right, to the left, or to the center. So for example, we might want to determine to create a histogram for the math score column numerical variable. So we apply a plot function to the column, and then inside that function, the plot function, we specify some parameters. So we specify the kind of plot that we want. If it's a hist, if you scroll your mouse on top of, okay, it doesn't show us, but if you go to the documentation, you will be able to see other values that are supported for kind parameter. But here for histogram, we just used hist. Then bins, for histogram, normally you have to specify the number of bins. Here we just specify 10. Color of the bins, for each and every bins, not more like the bars within histogram. We want it to be sky blue. You can change this to hex code value, which is just a way of representing colors using numbers. Then the edges of those bars or the bins, we just specify we want them to be black for just ease of just for aesthetic purposes. So, and we put a comma or a semicolon at the end to just specify that we are done visualizing. This is just a way of just being able to display a plot. But you can also do that using matplotlib, but in most cases we usually use plt.show, but we are not going to be importing another library like matplotlib for visualization. All right, so if we run this, we can be able to see now our visualization. All right, pause the video and then work on the challenge here. All right, so that's it. So that's it with regards to this challenge. I hope you were able to cover a lot. You were able to grasp and continue practicing. The idea is that by the end of it all, at the end of this Pandas challenge series, you should be in a position to be able to just work with Pandas for data analysis, for data manipulation with ease, without a lot of struggle. It should feel second nature. Right, all the best in your learning journey. If you loved this learning experience or this challenge, and you'd want us to continue creating more challenges, be sure to give this video a thumbs up. And if you'd want to be informed when we post such future courses or such future learning experience or challenges, be sure to subscribe, and see you in the next one. Bye-bye.